Okay, so thanks everybody for attending. And today I'll be talking about why you should care about IP-XACT. I'll get right into it. So basically, IP-XACT is all about delivering IP from IP providers to IP users. Certainly there's folks that use it for other things, but this is its main purpose in life, is to provide a way for IP providers to package their information and deliver it to their IP users. So the kinds of things that gets packaged are the ports and interfaces, and there's enough port and interface information so that you can connect your IP to the rest of the design. Let's say you're assembling an SoC and you have IP, perhaps internal or external, and you want to connect that IP to the rest of the design. And so IP-XACT has metadata that tells you what all the ports are, and so you know how to do that. So you don't actually have to parse the system Verilog or VHDL or even old Verilog files to find out what the ports are. They're listed out in the IP-XACT file in a way that tools can use to automatically hook up the design. Another piece of information that's that gets packaged in IP-XACT is metadata about the hardware-software memory map. So this is the software interface into your IP. And this has enough information so you can create some header files for your firmware, basically information about where the registers are in the address map and the fields in those registers and how those fields behave when software interacts with them. Another piece of information is the file manifest. So normally when you get an IP, there's a large number of files you get. You may get some RTL design, and that RTL design could be in several different languages, or you may get some prototyping information. Let's say you have a virtual prototype that comes with the IP and the files that are coming along with that. Maybe you have some physical design files. So there's all sorts of files that normally come with an IP, and the IP-XACT file identifies what those files are and where they appear inside the package. So I guess you can ask the question, so I'm interacting with an IP provider, either internally or externally, and how do I find out about what this IP is, and so that I can use it in my design? And you know, in the old days, maybe you get a PDF file, a Word document, you know, napkins, something that has something scribbled on it that says this is what this IP and what it does. Now, clearly, that's not a great choice. At best, you have to copy the information from the PDF file or whatever and enter it in another format. And so that's right there, just involves a manual process with a lot of screw ups. And usually the other problem is that the documentation and PDF files are out of date or incomplete or inconsistent with the IP you have actually just received. Some folks use spreadsheets. This might be a step up. At least in some sense, spreadsheets is something that some scripts could read or process. And it's a format that you can work with and familiar with. But you have the same problems realistically. Nobody's spreadsheet looks the same as somebody else's spreadsheet. So you're always hunting for, okay, what's the information? I have all these cells in my spreadsheet. What do they mean? And what do I do with that information? And I guess that's sort of a segue into the other thing. Also, a lot of teams have their own custom XML files they just came up with. And there's all sorts of container formats for data, basically name value pairs, maybe structured. And there's all sorts of formats out there that you can work with. But the bottom line is there's really no guarantee that anybody else can read that file. Are there tools available? Are third-party tools available? Does anybody know what's in this file other than perhaps the person who originally wrote the script that processed them? So I guess what I would say is, well, one smart thing to do is work with an industry standard. And industry standards have the benefit that, well, they're published, so everybody knows what they are. The vendors are motivated to implement interfaces to those standards. And it would be great if the IP providers would also adopt the standards. So let's talk about some standards. So there's choices. And right now, the Accelera and IEEE have some standards published with respect to the IP that people work with and all sorts of aspects of that IP. And so let's talk about these individually. So we have a System RDL, and that was published in 2017, the most recent version. And this particular standard right now is, we're not sure which way it's going, but it doesn't look like it's going in a good direction. But it does have a lot of benefits. First of all, it specifies both the hardware and software behavior of your hardware software interface. So not only does it tell you what happens when software interacts with the registers and fields, but it also has some information about how these registers and fields interact with the hardware they control. Unfortunately, this particular standard doesn't have a large amount of information about hardware behavior. And a big flaw here is that it doesn't have almost no information about the port and slave interface specification. And oops, I see a mistake. Slave should really be target. The industry is trying to move away from this terminology. Then we also have IEEE 1800.2 UVM. And this is pretty awesome because it was just published last year, and adoption is growing. So a lot of people are very enthusiastic about UVM. The committee is currently working on helping folks that are still using the older versions of the standard. So Accelera published this way back in, let's say, 2010. And in the first couple of versions, a lot of people are developed entire environments around it. And now the IEEE was published in 2017 and again in 2020. And there's some roadblocks in moving your environment forward. So the committee is working on seeing how they could smooth that process out. So this standard is useful because it does actually talk about the register address map and also gives you information about what happens when software interacts with the registers. Now, once again, this has some limitations. Basically, this is just for system verilog verification, and it has no information about the hardware behavior. In other words, you have registers in the fields, they interact with the hardware, but this standard doesn't tell you what happens there. So that's a limitation of this standard. And likewise, it has very little, almost no information about how the IPs are connected to one another. All right, portable stimulus. The 2.0 version is out. We're rethinking that. The industry is starting to look at that and starting to use it. The committee is currently gathering requirements for the next version. The strengths are that this particular standard also talks about hardware-software interface, but in this sense, it's more of a programmatic kind of way of looking at it. Sort of how does one program the IP? And it also incorporates some information about the hardware-software interface, but realistically, it's only enough for a C header file. And so in that regard, it's quite limited. And that gets us back to the start of our conversation, IEEE 1685 IP-XACT. So the most current version was published in 2014, and yes, that was a while ago. The good thing is that the industry is really starting to embrace IP-XACT. After, gosh, almost 20 years of effort, the industry is actually starting to use it. And the folks here at Semifore, our customers, are running into these files all the time. Now, the committee is been quite active for the last few years. Most recently, the last, I would say 3 or 4 years, there was a lot of activity in the Accelera version of IP-XACT, where the committee gathered some requirements and developed new features and updated the standard. And that became a contribution to the IEEE, which was handed over just a few months ago. And now the IEEE committee has been reactivated, is busy on working on working towards the publishing of this standard. And right now we think that's going to be next year. So once again, it models and specifies the interconnect. So the ports and interfaces, so you can wire up your SoC and put your IP in there. Basically packaging what files are in the delivery that you got, and it provides the hardware software memory map with the software behavior. And just as a sneak peek, the new version of IP-XACT is going to have an even more elaborate software behavior capability than the old version. Now, the current version does have some weaknesses. The first of all, the IP-XACT does not really specify any hardware behavior other than interconnect, in the sense that things are connected, but doesn't tell you how they wiggle or anything like that. So the idea here is that the actual model of what your IP is doing is something that would be incorporated in the files that are packaged with the IP-XACT delivery. So in other words, you would get, let's say, System Verilog RTL files along with your IP-XACT files, and the detailed hardware behavior would be in that RTL file. Now, there's some weaknesses as well. The old version of IP-XACT of 2014 had some issues with the backdoor paths. The new standard is going to address those. And I do want to mention that even though the standard has been around for 20 years and the industry adoption is growing, that there's quite a few folks out there that believe that they could type the IP-XACT files in basically by hand. And that's not realistic. The standard is quite elaborate, and handles a lot of information associated with an IP. And realistically, there's a lot of rules and schemas that have to be followed in order to be basically be IP-XACT compliant. And what we found through our customers is that there's a lot of IP-XACT files out there that have been created by dubious methods that have resulted in basically files that are unreadable, or certainly, I mean, they might be called IP-XACT, but they certainly are not compliant whatsoever. And so that's basically is a headwind for the industry, is how to create these IP-XACT files. And we'll be talking about some options there. All right, so we've talked about some random file formats and some other standards. And realistically, today in the industry, IP-XACT is the only choice for how an IP provider should package their IP for their customers. Realistically, the other standards have limited scope. And likewise, the other file formats, who knows what scope they have, but that's the issue right there. Nobody knows what those file formats are. Realistically, a lot of these files that are basically in some standard format are probably meant to be incorporated in an IP-XACT packaged IP. So in other words, IP-XACT is not, I guess, an alternative. It's let's say if you have some UVM files, yeah, you can incorporate them in your delivery to your, so the IP provider could put that in the delivery for the IP consumer. So basically, IP-XACT is for delivery, whereas some of the other file formats are being delivered. Okay, so standards fall short. Unfortunately, the reality is the everything standard does not exist and probably never will. And IP-XACT is, although it has a lot of information about the IP, it clearly does not have everything about it. And the committee has been very careful to limit the scope of the standard itself. So first of all, standards don't have all the information in it. The second issue is that we've talked about several standards published by the same organization, Accelera, and there's some slight nuances in each standard where they're slightly incompatible. And certainly Accelera has an initiative to resolve those kinds of issues. They still exist and probably will exist for some time. So that's another area where they fall short. And of course, each standard has, I guess I would call it a data model for how what kind of information can be captured in that standard. And maybe that data model doesn't exactly match with the design that you have at hand. So that's things to be aware of, is that none of these standards are all encompassing or can deal with every kind of design. So that's something to think about. Another thing I want to talk about is the anti-standard, and certainly IP-XACT has a lot of, I guess, escapes. So in IP-XACT, there's a concept of vendor extensions, and throughout the IP-XACT schema, you'll find places where you can just insert vendor extensions, and you can choose whatever vendor extensions you want. And realistically, this is an area where you can get yourself into trouble. Well, first of all, one big no-no is using the vendor extensions to hold information that's already part of the standard elsewhere. Realistically, if you do that, you'll hand the file off to, let's say, a third party or to a tool flow, and they're expecting information to be in the standard place and have no idea that you've hidden it in another place. And realistically, you could end up with an illegal design, or certainly not the design you had intended. And likewise, with things like vendor extensions, realistically, maybe only your own tool flow could deal with it, but no third party can deal with it because they don't know what your extensions are. Or if one of your vendors uses, let's say an IP provider uses extensions, is there a tool flow out there that can actually process that information? Is it even available to you? So I would very strongly suggest to be very careful about using things like vendor extensions in IP-XACT. And a better path would be to work with the IP-XACT committee to get new features added to the standard. Now, that being said, vendor extensions are an excellent way to prototype those kind of new features for the standard. So in that regard, that's sort of a good side about the vendor extensions. It's a way for us to prototype new features that we could eventually put into IP-XACT, and that's actually happened over the years. And even Accelera itself publishes extensions to the IP-XACT standard for certain purposes. I guess the main purpose is the committee was not ready to incorporate some features into the standard, but there were some customers or users of the standard that want to try out a new feature and managed to define it to the level where Accelera could at least publish them. But all this being said, be careful with using vendor extensions. It's not the escape to allow IP-XACT to be everything that you might want it to be. Basically, realistically, IP-XACT can be only what it's in the standard. Okay, some more options for capturing information. So one thing to be very clear about for IP-XACT is the committee has no intention of expecting anybody to type an IP-XACT file in by hand and use that to create a design. That's not what IP-XACT is for. And realistically, we don't actually expect human beings to look at it. It's really a tool-to-tool interchange format so that, let's say, an IP provider can provide information to the customer and the customer tool flow to automate that handoff. So then you might say, well, part of my job is to actually create IP. And the question is, how do you author the information about that IP? And here at Semifore, we do have alternatives. we do have a domain-specific language for handling the hardware-software interface called CSR spec that contains a lot of information about both the hardware behavior and the software behavior. And the hardware behavior is quite elaborate and contains enough information for the ports on this particular design. And so we're getting close to the end here, and I just want to also mention that the CSR compiler processes that information and works with industry standards like IP-XACT. So IP-XACT is an input and output of the CSR compiler. So I mentioned before, one of the main issues with the industry right now is there's a lot of bad IP-XACT files out there that were created either by hand or by some random set of scripts. And realistically, they're not compliant with the standard. So using a flow where you use CSR spec to author your information and use the compiler to generate the IP-XACT, that way you can create IP-XACT that your customers, either internal or external, can work with. And likewise, the CSR compiler accepts IP-XACT from other parties and will first of all verify that it's a legitimate IP-XACT file, and then that goes even further to make sure that all the semantic rules of IP-XACT are followed, and then to make sure that even more so that the design is self-consistent and valid before generating any other outputs. And the CSR compiler can generate outputs for certainly the RTL team and the verification team and even technical publishing teams for documentation. So now I'd like to look toward the future and open the floor for questions.
I've got two questions from the audience. One is IP-XACT. IP-XACT is an XML schema, right?
Yes.
Are the dubious files mentioned still passing that? And what is wrong with them if it is?
Okay. Thank you. So yes, so part of the IP-XACT standard is an XML schema. So at a very first pass, if you have a file that claims to be IP-XACT, first, it has to be a well-formed XML file. So it has to follow the rules of the XML standard itself. And then the next step is it has to follow the schema that was published with the IP-XACT standard. In other words, the names of the elements in the file have to match the names in the IP-XACT schema. The elements have to be in the right order, and the element values have to conform to the values that are specified or required by the elements in the standard. So that's all very true, and there's a lot of tools out there that can verify that an XML file is valid. In other words, it's well formed and follows the schema. But for IP-XACT, that's just the beginning of the journey. So there's also a set of semantic rules in the standard, and those semantic rules make sure that the various elements work together in the way that was intended by the standard, and that the design that you're describing actually is self-consistent. So even though you may pass an XML validity tool, a tool that checks a file XML's validity, you may still violate all sorts of IP-XACT rules. And so realistically, those issues have to be addressed. And so we do see quite a few files out there that have all manner of violations of the semantic rules. But realistically, if you look at the file, often that basically also means that, hey, there's something wrong with this file. This IP-XACT, this file that you claim to be IP-XACT doesn't actually describe the design. And in fact, it's sort of wrong. And so realistically, the semantic rules are to help the industry create descriptions of designs that make sense. So I hope that answers the question.
Yeah, another question from the audience. What does CSR compiler do with vendor extensions from the other providers?
So realistically, the vendor extensions, some of them are published. So various vendors or let's say EDA companies work with a certain set of extensions, and they've published definitions of those extensions. And so for those published extensions, the CSR compiler is able to either extract on the read side, extract those extensions and interpret the information in them and include that in the design. And likewise, if in the other direction on output, if the CSR compiler is generating files that are intended to be used with a tool flow that uses these vendor extensions that have been published, the compiler can insert them in the appropriate places with the intended meaning. Now, for the unpublished random vendor extensions right now, that information is, I guess, would be removed from the description because there's no interpretation for it.
All right. Well, thank you, Rich, for your time today. We are at time, or a little bit before, a couple of minutes. Anybody else have any questions? Or if not, we can...
Yeah, I can jump in here, Josh. I think we just got a couple of minutes left here. So, and Rich, you sort of touched on this a little bit already, but I'd like your broader view of this. You know, you mentioned that there's a lot of bad IP-XACT files out there, poorly constructed ones. What's your advice here? How can the industry get better or higher quality IP-XACT? What's the approach here, do you think?
Well, the real approach is to work with a tool provider that provides IP-XACT tooling, and that way you can just generate the files correctly from the get-go. And I know, some people are hesitant to that, and the alternative is actually quite long. I mean, the standard IP-XACT standard is very large, and takes somebody a tool developer, a long time to understand how it really works. So I think that the best plan is to work with existing IP-XACT tool providers so that you can generate IP-XACT files that are correct from the get-go.
All right, one last question from the audience. Has there been any attempt to make IP-XACT XML more human readable? Think considering JSON or HSON?
Realistically, JSON and formats like that are not that much different than XML. There's this concept of name value pairs. In other words, you have a name and that name is a container for something else. And the tricky part, of course, is what are those names exactly? What do they mean? Which containers can be inside one another, and what values are allowed inside the containers. And realistically, the IP-XACT schema is really not much more than that. And realistically, things like JSON and YAML and even XML itself are all various ways of structuring files and giving names to data. And realistically, right now, I don't see any difference between them as far as readability. No matter what file you get or what format that is, you still have to understand the meanings of the names and what the values mean and the relationship between the containers.
Well, thank you everyone for your time today. And you all have a great Hot Chips 23 or 33. Thanks everyone for attending.